After completing this lesson, you will be able to define what fine-tuning is in simple terms, identify use cases where fine-tuning excels, understand the difference between base model capabilities and fine-tuned capabilities, recognize when fine-tuning is not the right solution. Fine-tuning is the process of taking a pre-trained language model and giving it additional specialized training to make it better at specific tasks or behaviors. Think of it like this. A base model like GPT 3.5 or Llama 3 is like a new graduate from university. They have fundamental skills like reasoning, logic, and common sense, but to put them in a specific job, you need to give them additional training. Fine-tuning bakes knowledge directly into the model's weights, so it knows how to handle specialized tasks without needing external context. When you fine-tune a model, you're 1. Adding new knowledge, facts, domain expertise. 2. Teaching new behaviors, writing styles, personalities. 3. Improving specialized tasks, medical diagnosis, legal analysis. 4. Changing how the model responds, format, tone, structure. Does not give real-time information, knowledge is frozen at training time. Cannot easily update, requires retraining to update knowledge. Not ideal for frequently changing data. That's what retrieval augmented generation is for. For the past 12 months, one area has been improved dramatically in 2024. The gap between top closed source models like GPT and the best open source models has decreased dramatically as Meta introduced Llama 3.2 and all the models Mistral has introduced. This is great news for AI developers because you can take open source models, fine-tune them for your specific use case, deploy them anywhere you want, no AP, costs, or rate limits. Example, medical imaging analysis. Base GPT-4 can read images, but struggles with specialized medical scans. Fine-tuning on medical imaging dataset teaches the model to recognize patterns doctors look for. Result, accurate analysis of X-rays, MRIs, CT scans. Example, legal document analysis. Default models don't understand jurisdiction-specific legal language. Fine-tune on case law and legal documents from your jurisdiction. Result, model that follows specific legal processes and understands precedents. Example, AI companion with personality. You want an assistant that's sarcastic, funny, or speaks like a specific person. You can't just prompt, "Be funny." The model won't be genuinely funny. Fine-tuning on demonstrations of that personality actually works. Example, celebrity voice, style mimic. Want a model that talks like Paul Graham, Warren Buffett, or your favorite author? Collect their writings, speeches, interviews, fine-tuned to capture their unique way of expressing ideas. If you're building an AI companion or trying to mimic the way certain celebrities speak, like being sarcastic or a bit rude, default models simply won't have that, and you can prompt it to maybe 80%, but to get really high fidelity of mimicking the way someone speaks, you actually want to fine-tune it. Example, structured output generation. You need the model to always output valid JSON in a specific format. Prompting can get you close, but fine-tuning makes it reliable, critical for production systems that pass model outputs. Example, creative tasks, ASCII art, poetry, generating beautiful ASCII art or specific poetry styles. Very hard to describe beautiful in a prompt. Fine-tuning on examples teaches the aesthetic. This is a huge practical reason. Many of you have worried that using models like GPT-4 for your production app is too expensive. However, you can totally accumulate certain usage, and then you can use those data to fine-tune a smaller and faster model to dramatically decrease the cost. The strategy: 1. Start with GPT-4 for your app, high quality. 2. Collect user queries and GPT-4 responses. 3. Fine-tune Llama 3 8B on this collected data. 4. Switch to your fine-tuned 8B model. 5. Result, 10x lower cost, similar quality. Problem: hospital needs AI to help process patient symptoms and suggest possible diagnoses. Why fine-tuning? Medical terminology not well represented in base models, need to follow specific diagnostic processes, must output in structured format for EMR system, legal requirements for audit trails. Solution: fine-tune on medical textbooks, anonymized patient case studies, diagnostic flowcharts, hospitals' specific protocols. Problem: Company wants to reduce support ticket volume with AI. Why fine-tuning? Company has specific products, policies, jargon, needs consistent tone-matching brand voice, must refuse certain questions. That's not my department. Should improve over time based on real conversations. Solution? Fine-tune on historical support conversations, product documentation, company style guide, escalation protocols. Problem: author wants AI assistant that writes in their style. Why fine-tuning? Writing style is subtle and hard to describe in prompts, needs consistency across long documents. Personal voice is unique. Solution: fine-tune on author's previous books, journal entries, correspondence, outlining style. Fine-tuning isn't always the answer. Don't fine-tune if stock prices, news, weather, real-time data, rapidly updating documentation. Use retrieval-augmented generation instead. Need hundreds to thousands of examples for quality fine-tuning. With 10-50 examples, few-shot prompting might work better. Try few-shot prompts first. General questions, common tasks. If GPT-4 or Claude already do it well, why fine-tune? Use the base model via API. Fine-tuned models are black boxes. Can't easily explain why it made a decision. Use rule-based systems or retrieval-augmented generation with citations. 1. Fine-tuning embeds knowledge into model weights, unlike retrieval-augmented generation, which adds context. 2. The gap between open source and closed source is shrinking, making fine-tuning more practical. 3. Best use cases: domain expertise, personality style, specialized tasks, cost reduction. 4. Not ideal for frequently changing data, very small data sets, tasks base models already handle well. 5. Think of base models as new graduates. They have fundamentals. You're giving specialized training. 1. What analogy is used to describe base models? Answer: base models are like new graduates. They have fundamental skills like reasoning and common sense, but need specialized training for specific jobs. 2. Name 3 use cases where fine-tuning excels. Answer: any 3 of? Adding domain knowledge, teaching personalities, styles, specialized tasks, structured output, cost reduction, behavior that's hard to prompt, creative tasks. 3. Why might fine-tuning not be the right choice for a news chatbot? Answer: news changes frequently, in real time. Fine-tuning freezes knowledge at training time, so up-to-date information would require constant retraining. Retrieval-augmented generation is better for dynamic data. 4. How can fine-tuning reduce costs compared to using GPT-4? Answer: collect GPT-4 responses on your use case. Use them to fine-tune a smaller, cheaper model, like Llama 3 8B, then switch to the fine-tuned model for production. Get similar quality at 10x lower cost. 5. True or false? You can easily update a fine-tuned model's knowledge by asking it questions. Answer: false. Knowledge is baked into the weights during training. To update, you need to retrain or use retrieval-augmented generation for dynamic information. Think about your own use case. Write down your answers. 1. What problem are you trying to solve with AI? 2. Does this problem need specialized knowledge or behavior? 3. Does the information change frequently? 4. Do you have access to enough training data, 100 plus examples? 5. Based on this lesson, should you use fine-tuning, retrieval-augmented generation, or both? Keep these notes. You'll refine your project idea throughout the course. Choose your project direction. Before moving to the next lesson, decide on a project direction you're interested in. Domain expert bot, medical, legal, technical. Personality transfer, celebrity style, brand voice. Creative tasks, writing, art generation. Structured output, JSON, SQL, code. Translation, multilingual. Other, describe. You'll refine this throughout the course and implement it in Module 7. Now that you understand what fine-tuning is, let's explore the alternative. Lesson 1.2, Retrieval-Augmented Generation versus Fine-Tuning Decision Framework. Questions? Reread the sections above or check the video transcripts in transcripts for more examples.